Okay, this is the Math 6 Unit 5A review. Alright, so starting with the first problem. When rolling a dice and flipping a penny, what is the probability of getting a 6 and a tails? So you could make a table here, you could make a tree, you could make a list. I'm going to make a table. So on the top, I'm going to have my options for rolling a die, and there are 6. And then on the sides, I'm going to have my coin, heads and tails. Okay, so this is 1 heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, and 6 tails. So they asked for the probability of getting tails and a 6. So this is the only one that we get both a 6 and tails. And so that is 1 out of, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total. So our probability is 1 out of 12. All right, the next one. Janet's Halloween bag contains 2 Jolly Ranchers, 4 Snickers, 4 packages of Skittles. Her brother's contains 5 Twix bars, 1 package of Skittles, and 4 Jolly Ranchers. You are blindfolded and must pick 1 candy from each bag. Give the chances of obtaining each of the following. So, you could make a table here, or you can remember, and I'm going to change this a little bit, you can remember that you can multiply those fractions together, or those probabilities together. So if I'm thinking about the first one, our first bag, Janet's bag, contains 2, 4, which is 6 plus 4 is 10. And the brother's bag, 5 and 1 is 6, plus 4 is 10. So they both contain 10 pieces of candy. Now, to get Skittles from Janet's bag, she has 4 out of 10. And to get Skittles from the brother's bag, his is 1 package out of 10. So that probability is 1 out of 10. So then we're multiplying. 4 times 1 is 4. 10 times 10 is 100. We could also say 1 out of 25. They are both divisible by 25. So there's my probability. Alright, so then the Jolly Rancher and a Twix. Well, Janet's doesn't contain a Twix, so the Jolly Rancher has to come from her bag, which is 2 out of 10. And then the Twix comes from the brother's bag, which is 5 out of 10. 2 times 5 is 10. 10 times 10 is 100. We can simplify that to 1/10. Alright, a Snickers and a Twix bar. Now Janet's is the only one that has a Snickers, so we have to have hers. The Snickers has to come from her bag, so we have 4 out of 10. And then the Twix has to come from the brother, so that's 5 out of 10. 4 times 5 is 20. And 10 times 10 is 100. We could simplify this to 2 out of 10. Okay, and the last one, a Jolly Rancher from each bag. Janet's probability of a Jolly Rancher is 2 out of 10. The brothers' probability for a Jolly Rancher is 4 out of 10. So now we have 2 times 4 is 2 times 4 is 8. 10 times 10 is 100. We could simplify this. If we divide by 2, we get 4 out of 50. And if we divide by 2 again, we get 2 out of 25. All right, so there's that one. Make sure you show some sort of work on how to get those. All right. At the ice cream shop, the menu is listed. Create a list, table, or make a tree. I like a tree for this one. So we start with our dot. The first thing we're choosing is our base flavor. How many base flavors do we have? Well, we have vanilla and chocolate, so we have 2. Vanilla and chocolate. And then after we choose our base flavors, we have 3 mix-ins to choose from. So I'm going to make 3 lines coming off of each of those. Cookie dough, Oreo, and sprinkles. Cookie dough, Oreo, and sprinkles. How many possible combinations are there? If you're getting an ice cream with a mix-in, we count here 1, 2, 3, 4, 5, and 6. However you do it, make sure you show how you got that answer. All right, part 2, numbered operations. Complete the representations of a portion web. Make sure the fraction is completely simplified. Okay, so let me zoom in a little. Okay, so if I'm looking at that decimal, 6.6, that 6 is in the tenths place, so we can say this is 6 over 10, which is not fully simplified, so I'm going to divide. Well, I know they're both divisible by 2. 6 divided by 2 is 3. 10 divided by 2 is 5, so there is my simplified fraction. Now you can have both, but make sure to have that simplified. So for my words, I'm going to either write how I would say that 6/10 or 3/5. It doesn't matter. I will go with 6/10. And then I know I can either move this decimal 2 places and this becomes 60%. I can multiply by 100, or I can just know that 6 whole columns if we're thinking about our 100% block. These are the tenths places are columns, and I can count by tens. 10, 20, 30, 40, 50, 60. So there is my final answer. All right. Use order of operations to simplify. First thing, circle our terms. So I don't want any addition or subtraction that's not inside parentheses. So there's a term, 11 on its own, the 2 plus 3 inside parentheses, and the 9. So this stays as 11. 2 plus 3 is 5, and then plus 9. Now I have just addition and subtraction, and I'm going to go left to right. 11 minus 6, or 11 minus 5 is 6, add 9, and I get 15. All right, the next one, I need to circle my terms again. I'm going to circle 4 on its own, and then I have the 5 multiplied by 1 plus 8, and then 2 on its own. 4 isn't going to change, but this is going to become 5, and then I need to do the parentheses first. 1 plus 8 is 9. 5 times 9 is 45, and then I'm going to subtract 2. I again just have addition and subtraction, so I need to go left to right. 4 plus 45 is 49. And then I'm going to subtract 2, and I get 47. Alright, this one, I'm going to make sure all of my decimal points go out to the same place value. So we're going from least to greatest. These ones go out 3, so I'm going to make sure all of mine at least have 3 decimals, or 3 numbers after the decimal. So this becomes 200, 2, 202, 220, and 22. So now that I can just see those parts and I can ignore that 0 at the beginning, I can put these in order. So 2 is the smallest, so I have 0.002. Then I have 22 is my next smallest, 0.022. Then I have 0.2, or 200. Then 202. And then 220. Alright. Same thing here. I want to make sure they all go to the same decimal point and make sure that my front number is the same, my whole number. So this is actually, once I add my 0, I have 40 and 40, which is equal. If I just ignore that 5, since they are the same, I have 1 and I have 10, so 10 is bigger. This one, I have 3, and then I have 30. 30 is bigger. Okay, your front number is the same. Oops, not that one. And this becomes 212, and this is 2,000, so that doesn't make sense. I need to add another 0. This is 2,120 and 2,012. 2,120 is bigger. Alright, and our last question. Write an algebraic expression to represent the following. Let x represent a hip-hop jump. So, we have 6 hip-hop jumps and a jump of 5. 6 hip-hop jumps, if x is a hip-hop jump, we would write as 6 x's, or 6x, and then a jump of 5, we're going to add on that 5. The next one, 2 hip-hop jumps and 2 jumps of 2 and 8 hip-hop jumps. Well, 2 jumps of 2 would be 2 plus 2, and then 8 hip-hop jumps would be 8x, or I could do 2 times 2 plus 8x. All right, there we go.